Our second speaker will be Professor Davide Presti, who is an assistant professor and holder of the Rita Levi Montalcini Fellowship at the University of Palermo, Italy, and he's also visiting academic at the University of Nottingham, United Kingdom. His expertise is sustainable engineering with a focus on transport infrastructures, technology development, and asset management. His research is both applied and fundamental, and involves investigation of effective techniques for recycling waste or secondary materials into civil engineering applications such as roads, airports, and railways. So given that Professor Presti is specializing in smart technologies, life cycle management, and multi-criteria decision-making, he will hold presentation under the title Towards Smart Transport Infrastructure. Professor Presti.
Thank you, Mr. Chairman. Really appreciate that. And good morning, everyone. Ladies, gentlemen here, but also the people that are home and looking at us through Zoom. Well, as I say to my colleague, I think this event is really a gift that Belgrade made to itself. But I'm very honored to be part of this gift because I really admire the presentation yesterday's. Really all interesting, and I look forward for the presentation today. So I really want to thank you for inviting me in this beautiful and vibrant and crazy city of Belgrade, which I like. And I want to thank Goran, Marko, also Miroslav and Ivan for their professionality, hospitality, and friendship, which I really value. So why am I here? I've been invited to talk to you a little bit about what we think is smart infrastructure. I don't tell too much what I've been doing, but I'm spending my time between the two countries. I'm now back home in Italy, but I still work in the UK. And in the last 12 years, we've been working in this field. So very briefly, we're going to talk you what we call SMARTY, which is our vision for smart transport infrastructure. And then mentioning the main project that we've been carrying the last 4 years, which is about to finish. We're going to look about some of the prototypes and what we define the guidelines. By the way, the guidelines are still not in the paper, but I'm going to show you is something brand new. And then going to conclusion. But before I give you my opinion, at least of what is a smart transport infrastructure, I really would like to know yours. Because people talk about smart transport infrastructure, but what is it? Can I have an opinion from you? Anyone? Maybe someone with a microphone can help. That can be one. No conjunction. I repeat for the people who are not listening. Adaptable. So it can easily adapt to any risk or any inputs, any hazard. I agree with that. Anyone else? Self-control, so it kind of has some senses system. Which goes back to kind of what is I would say, the most common way of seeing smartness, which is giving some intelligence, right? And actually this is what, I will say possibly the beginning of the talks was stated by the Royal Academy of Engineering in the UK. Well, basically you need to have a sensing system that gets data. You get this data through some sensors, and then you start analyzing them so that you can have, some information. And then you start to have feedback, possibly directly from the infrastructure, to then through some decision making, adapt the infrastructure to that new situation. So we give this intelligence, and this is what I believe it's what we still think is a smart infrastructure. But then we've been thinking, well, we do need to give this intelligence, but the problems that infrastructure are facing are manifold. It's deteriorating, there's an increase in demands of traffic, shrinking budgets is a problem. So yes, having data can help in this, in improving decision making. But then also there is increased expectations. People want to move more. But what about climate change? What about anthropogenic hazards, now terroristic attack? And then we have sustainability, and then we have equity and safety. How smart has to be this infrastructure? How intelligent it can be to face all these problems? But then, after all, certainly smart, it's intelligent. But we shouldn't forget that possibly another approach is to actually find that elegant solutions with good judgment, with good engineering judgment, that I know that we all have, or possibly sometimes, because of where the money is, we tend to forget. Possibly that is a smart transport infrastructure. It's an infrastructure where we use our elegance to find good solutions. And that's exactly what we think. That smarty is, a smart transport infrastructure is a system designed, constructed and managed by adopting an integrated approach of solution found with good judgment, so that we can actually face or cope with the main challenges of our time. We need that intelligence, but we do need good judgment. And that's where our vision came from. We wanted to basically having some principles that I'm going to show you to form this vision, and then trying to do some research to find some prototypes and possible guidelines to go towards this type of vision. And for instance, this was what we came with. An integrated approach where we are gonna, actually we played a bit with the name, where smart in this case is sustainable, multifunctional, automated, resilient transport infrastructure. But really the message here is that we should analyze each of this sector and trying to find an integrated approach, always having good judgment in mind. And that was the project about. So we thought first of all that in order to go towards this vision, you should acquire multidisciplinary competences. That means that we should all work together. All these technologies, all these approaches that we have seen, they have to come in place. And it should be international. And of course, collaborative research, but let's not forget about training. Because this is such a cultural change that only education will lead into that. Other point, this solution, they of course need to go in each of these pillars as we defined, but we shouldn't forget that we have to go in each level of the development. We should have sustainable materials, we should have resilient infrastructure component, we should have multifunctional infrastructure network and so on. So it's not only by pillars, but we actually have to act in each of the level of the development, and this needs to be connected. And another way they can facilitate this implementation, I'm aware that most of you know that, but possibly some of you don't know about the technology readiness level, which is something that was developed by NASA at the beginning to understand technologies that were developed in NASA at which level of development they arrived. Well, now most of the projects are, whenever you prepare a project, you have to state your technology readiness level, and they're really helpful because they allow us to understand where we are at the development stage, which type of stakeholder should involve. So with this in mind, we have the incredible opportunity to actually get some funding from the European Commission to develop this European training network that wanted to implement this vision of Smarty. So the idea was to basically go from the infrastructure today to the infrastructure that I picture earlier on, so that they can cope with this type of challenge, through Smarty. But in this case, Smarty is not only working on the vision, but is mainly developing a new generation of researchers that with this background can then go in the next challenge and possibly change the way an engineering consultancy is working or the way a colleague at another university is working. So starting from the seeds. So we put together really big consortium, and I had the chance and really pleasure to coordinate this. And we had infrastructure manager, we had developer of different technology, what we call those smartening our system, as well as different colleagues from academia and industry. An idea, again, was to take all these different expertise, train 15 researchers to develop some prototypes and guidelines that then will be provided through our deliverable at the end of the projects. Because it's only through cultural change that we can arrive to this type of goal. So the real results really are these guys. They just finished, they finished a few months ago, and they're already working everywhere. And universities, some stays in company, but I'm really pleased that they are working on projects they developed, almost all of them. So we trained them, first of all, in each of the pillar, organizing training weeks with experts all around the world, in different parts of the world. We arrived even to Australia to do that. And then we developed different research projects on roads, railways, airports, looking at different level of what we call the transport engineer ecosystem. And these projects were all interconnected. And now I would like to show you some of these prototypes, some of these ideas. And they're mainly here for road pavements, but you may find it also for airports and railways in our website, and now it's filled with all this information. First of all, what is a sustainable transport infrastructure? Well, it's designed to last, first of all, but it has to try and maximize recycling by minimizing the impact. This means that in our vision, when we look at technology development, we should use the way we usually use to do technology development. So we work with testing, modeling, on-site experience, but we should understand how to maximize recycling of any secondary material. But that is not the end of it, because who told us that maximizing recycling is actually sustainable? If it has a huge impact somewhere in the life cycle of the material, of the infrastructure. So we studied how to integrate sustainability assessment techniques within technology development. And this means life cycle assessment, as most of you know, but now there are different techniques that also go to life cycle sustainability assessment that takes all the three pillars to have a quantitative assessment of the impact. And we did it also to give suggestion at the asset management level. Because for instance, for road pavements, we do a design, then we possibly have a maintenance strategy, and whatever costs less goes in the field. Well, what we're suggesting is possibly already when you develop, and already when you are at a procurement stage, you should give this sustainable option that says, yes, this costs less, but this is actually the approach we want to take. And just a little bit out of this, but just to give you some other input, we actually developed a sustainability assessment framework for the Conference of European Road Director. We just finished the project which is called Pavement LCM. And we basically provide state-of-the-art on what is sustainability assessment, how to apply it for road pavement, and provide certain tools, guidelines, and resources to do it. So whoever is working with road pavements, this is all free access, and you can just go on the website. Well, within Smarty, we actually went a little bit beyond and tried to use with these techniques also finding some indicator for introducing circular economy philosophy into this picture, and specifically looking at some indicator like the material circularity indicators. I'm aware that for civil engineer, this is a completely another discipline. but I really suggest you to go and look into it and collaborate with colleagues that do it, because this is the present. In order to have good judgment, we should understand what is sustainability. Well, for each pillar, after having developed some prototypes, this is just an example, we then develop a roadmap of what we think can be sustainability in the next years. Right? We talk about technology readiness levels. Some of the prototypes are a certain level, but then we need to understand what is our current situation, what are our drivers, I mentioned already earlier on, and what is our vision. I'm going to show you this, which is really fresh, which just finished, but for the sake of time, I can't go in each of these details, but I'm going to be happy to share with whoever wants it. And possibly I'm going to mention just a few lines, like for instance, in order to maximize recycling in our vision, for instance, we should stop talking about the amount of recycled material, and actually we should focus on limit what we call virgin material. So we should use the less amount possible of new products and maximizing the secondary material. So just changing the way we look at things. As well as having circular system as an industry standards. And one important thing that is almost an excuse in many places I've been working with is that people are not trained for using this type of technology. Well, we need to train people in the plants, in the field. We need to, in the engineering, we need to train people in this type of philosophy. So I'm not going through the others, but I'm gonna be happy to share these roadmaps as well. Let's talk about what is a multifunctional transport infrastructure. Well, the idea is that roads, railways, not only network infrastructure, but also punctual, especially the network one, occupy the biggest slice of planet Earth in terms of infrastructure. If you think about that, you look at the Earth from the moon, you see all these roads. And possibly we should optimize this use of this land. Possibly we can give some other function, not just for transport, but we can start using this occupied land for some other functions. And this was at the, at the core of our thinking about the multifunctionality. So the aim is optimizing land use, but then trying to find some other function. And the first one, the one that we developed more, investigated more, was to have energy integrated systems. So a system that don't only function for transport, but actually they produce energy, for instance. And I'll give you some of this example. Domenico, that works at the Università Gustave Eiffel in France, he tried to develop a pavement that actually was a sandwich structure where you try to put the solar panel underneath, within some layers, because there would be different trials on putting solar panel over the road pavement, but over the surface, which gives problem with friction and durability. So they develop a transparent layer that gets dirty with the time, yes, but apparently it keeps efficiency of the solar panel to a minimum of 60%, which is anyway pretty good, and that can guarantee producing electricity, that it was actually good enough to start thinking using it for lighting or some buildings. I will say the also important thing here is that they tried to have a layer of porous asphalt within that, below that. Porous asphalt is an asphalt with a lot of pores, where some water can go through and can refresh the solar panel, so keeping the temperature down. But at the same time, this hot water can be used for some other purpose, still to harvest energy. This is still in development. They're developing the prototype a little bit more. Happy to give you contact to our colleagues if you want to. Other way of harvesting energy is to actually create a system to self-monitor. No? The colleagues was actually mentioning that. So we started using some sensors, and later on I'm going to show you another one, that can be integrated into the system or attached over the system, and with some piezoelectric membrane, they just create that enough energy whenever some vehicle pass by to give some power to electronics that is, tailor-made, so that we can start monitor what is happening. Maybe not everywhere in the infrastructure, but in some critical points that can be useful. Knowing the load that is on the infrastructure rather than knowing the tensional state. This is Maria that is working at Eiffage, and now she's still working there actually. Well, also for our multifunctional, we have our vision, our roadmap, and again, I just leave it to you for the sake of time. I'm not going into details, but certainly our drivers are also to optimize land use for this energy, integrate the transport infrastructure, and decarbonizing it through it. But let me go to the one that I would like to explore a little bit more, which is the automated one. With automated, we want that, again, intelligent infrastructure. So here we start to go towards what is the common understanding, possibly with some sensors that can provide proactive communication to managers, but also to users. So I'll go quicker now, try to keep your attention. First of all, which type of sensor we want to put in there? We can have sensor that we can install in the infrastructure, but we know that they usually cost. We have to sacrifice them. Then we have to think about recycling. So maybe we can't use installed sensor everywhere. Maybe we can use people, no? We can use cars to start and get in some data. So we can engineer the system to have different type of data. We can use our INSAR technology, no? Our satellites and geodesy. We can use different type of data. But then we should start thinking how to use the data. And certainly we want to improve the design of the infrastructure as well as starting to predict what is good to do for maintenance. Not just go and save the infrastructure whenever it needs it, but start predicting. So I'm going to give you some details of one of these prototypes. It's the one that I've been working, one of those that I've been developing. First of all, for pavement, this is for road pavements. What is an ideal sensor system? We want something that is low cost. It's civil engineering. If we want a cloud of points, it's too big, the infrastructure. We can't spend that much. Yesterday, the colleague was talking about €200, which is already quite cheap for what is around. But if we start going towards a cloud of point that can then give us predictive model, possibly we want something even cheaper. But it depends on the applications. But certainly we want something small size that possibly is not wired, some wireless, that doesn't have a battery. Something that we can install there and possibly kind of forget. Because then when we have to recycle that material, that infrastructure, it doesn't have to be a problem. And just to give you an idea, this is what we usually put in road when we have money, because one of these costs €800. And they actually have this H shape because it allows us to grab the material, not to move it, so it can stay a little bit in place. And they measure usually strain. These are strain gauges. But they have different problems. A solution, it's a technology developed by a colleague at the Michigan State University, which is called wireless piezo floating gate sensors. That's, in a nutshell, just to give you some comparison, a strain gauge depends on several factors. And in road pavement, we have loads changing, the temperature, and based on this factor, the reading changes. Another way, we should have a sensor to read the factors that calibrate our sensors. So it's a kind of complicated sensing system and expensive too. These sensors, first of all, it's a piezoelectric membrane. So the sensor itself is actually this one, the membrane. You can't see the arrow, but it's this vertical yellow part. And it activates like an iPad whenever there is an impulse. No? The iPad is the same thing. We can go through because we use our finger. And it allows to have, I'm going to show you a little bit later the detail, but basically it creates some energy that is stored in a wireless battery and this battery is only for the antenna, which is wireless. And it's this movement of the membrane itself that is actually the sensing system. What is happening is that whenever the wheel passes by and the piezoelectric membranes kind of bends, then some electrons, so a circuit is closed, and some electron goes in different gates that store this information. And it's just an electrical impulse, but it's stored at different level of impulse. So it's not a continuous reading, but actually this electron go and get collected. So this can be retrieved later, and we know how many electrons we have in a gate for higher loads rather than in a gate for a small load. This allows us to have traffic counting, or eventually even reading strains, as I show you later. But the good thing is that if we retrieve the data whenever we want, we don't have a massive amount of data, and we don't need a lot of power for the sensor. So we can actually put the sensors there, and these sensors in mass production can cost $10. That is why it's pretty attractive. So what we did is that we started understanding how to work with this impulse, because it's just an electrical impulse. And we calibrated this impulse with our testing that we usually do in the lab. And we had a pretty good calibration with the strain. And once we were happy with that, we actually used another project that I was involved in, where we installed all the sensors together with some actually commercial sensors, with same type of scheme. And for 1 year, we actually passed over some different type of asphalt mixture to understand what was happening. I'm going very quickly here, but usually, whenever we want to see cracks on a pavement and we want to see how to develop, we go there, like the kids, and we color, no? Each crack for after a month is yellow, after 2 months is red, and so on. And we actually visually see what is happening. And based on the extent of the crack, we say, oh, this is breaking up. So for some of the mixture, we realized that after 900,000 passes, just remember this number, this started to develop. So a big extent of crack started to develop. So that material was breaking. So what we did is then to use these sensors and try to understand the information it was giving us. So this is 900,000, right? And as you can possibly see, these are the curves. So 900,000 is the red line. The different lines are actually the level of reading of each of the gate. So we go from gate 1 to gate 7. What I just want to show you is that in 900,000 we have all the gates open. So basically it's saying that all the information are not, they're already given. But what we can start having is actually information on whenever the cracks is forming, and possibly whenever the cracks propagates, not just whenever the cracks appears in the surface. And this was possible because the sensor was installed just within, below the first layer. It's still really raw data. We still have no real information for decision making, but it's certainly a way that we are working on, because it can possibly be the future for asset management. So this is what Mario developed. This project where we could have these points in a cloud, and thanks to these sensors, having platform like BIM, no? Yesterday we seen a colleague, or any platform that can be used for decision making. We also have our roadmap. I'm not going to the detail. I just want to go very briefly in the resilient transport infrastructure, because for us, resilience, it's basically the capacity of this system to recover from difficulties. This is a common definition. But what I wanted to point out is that in order to be resilient, we first of all need to understand our risk, our hazard. Our colleague from the UK yesterday told us about floods. But there are other hazards. And we need to find that preventive measure to avoid the point of no return, Or eventually, if this is not possible, we just have to find some mitigation strategies. So whatever we do, it should be focused in having this type of good judgment. So we did develop some prototypes. These are part of the materials. Again, I'm going fast. Yesterday I was talking about self-filling concrete. Well, there are people working in Delft in this, but also working in self-filling asphalt. Actually, it was a guy that was in Delft, but now he's in Nottingham. And what it is, we try to self-heal cracks. And a way to do it is to put some capsules with some oil that is going to heal at least part of the micro cracks. This is not for big cracks, this is for really micro cracks. And it's shown that thanks to this, whenever we can manage to break these capsules, we can recover up to 80% of the initial strength. This is now actually developed in some of the Aguas England network. Another one, this is really nice for me. I was talking yesterday with Enrique now with some applied physics. So they started putting some ferromagnetic particles in the asphalt, and thanks to the stimulation of some magnets, they can actually change the stiffness of the asphalt, or possibly provide a coding that will allow the pavement to communicate with some external reader. And the example of this is that they made some reader, put some in the scooter. And what is the idea? Well, I'll try to show you a little bit better with this video. Whenever you see the app, now it becomes red. So basically, whenever the scooter passes by, the pavement is actually talking with the scooter. And as you see, the guy is going fast, and then passing there, he has to stop. So the pavement stopped the scooter, and this can have application, for instance, in urban area. When these guys with the scooter, passes by, it can try to stop them. It's just an idea now. Possibly you need to see some safety and so on. But the idea that the infrastructure can communicate with the user, well, then start to open new horizons. Another point that we actually start doing, this may be of interest to my colleague of yesterday. We started to use resilience assessment into network. So we want to take a network, this time with a multi-hazard approach, not only floods, but some other hazards, and trying to understand what is the state of resilience of our network. Not going to the detail again, I don't have time. So there is a roadmap for this as well. I hope that people can find it useful. And I want to conclude, Mr. Chairman, just to stay on time, and saying that, again, smart solution can be conceived and applied multidisciplinary competences, but education is really important at this moment. Not only of fellows or students, our education. And that's why I'm pretty happy to stay here today, because it's really a good platform to see what is happening around, also in other sectors. Life cycle thinking approach, but also this multi-level approach is very important. It can't just happen in material stage. We have to think what happens in the network. And I hope that these guidelines and technology readiness level is a good way to actually implement this idea. And I want to underline that the integrated approach of this different feature, well, that one is possibly the one that can give us the good judgment needed for smart infrastructure. This project was done thanks to the support of Europe, and Marie Curie European Training Network are an amazing platform to explore visions like this one. So I really suggest you to go through it. And if you want any help, I am lucky enough that I've coordinated the second project. And hopefully there will be some others soon. So I want to conclude saying that we need to cooperate, as our colleagues were saying yesterday. And civil engineering should certainly spend its effort in sustainability, but embracing these new technologies, not just with intelligence, but with a good judgment. So thanks to the European Commission for the funding, and thanks to all my colleagues. This is just part of it. It was a big, really big group. And thanks to you all for your attention.
Professor Presti, thank you very much for this interesting presentation and the lecture you gave. So I'm now asking you for comments, ask questions.
Thank you for very nice presentation. And I will ask about the cameras. I haven't seen cameras in your presentation, so I'm interested in if cameras are useful for your framework and so on. Does such a data are still useful or not? Because we can see cameras on every corner in our city or everywhere.
So we had 15 projects, all interconnected, and we have to select, of course, technologies, but we did actually look at cameras. And there is one project that looked at building a low-cost asset management for roads that compared the use of 3D cameras and LiDAR with data coming from mobile phones. And actually, the asset management tool was built, and it was shown that not for everything, but for the majority of the cases in an urban area, you can actually use mobile phones as well. We are not the only one working with this. There are different people, so I'll suggest you to go and look because it's really vibrant field with really good results.
Okay, thank you.
Please.
Slobodan Đorđević, University of Exeter. Davide, first of all, congratulations on being successful in getting an ETN. I'm well aware that it's one of the most difficult types of projects to get with a very low success rate, so well done on that.
Thank you.
You mentioned briefly, I believe you called it natural event, and there was a slide with some weather images. So did anyone work on observing weather parameters like wind speed and direction and temperature and rainfall intensity or perhaps water depth, and then on the basis of that making some decisions on, I don't know, closing some roads or traffic lights schedule and things like that? Thank you.
Thank you for the compliment. Mine is a very quick answer, no. But I'm aware of the importance, and it shows you that it's just such a wild field that we do need to merge expertise and integrate the approach, but I certainly take the point.
Thank you. Please.
Yes, thank you very much for educational presentation for all of us and encouraging with respect of ETN. So my question is, what is your next idea for ETN?
Right. Well, first of all, you have to know that ETNs are a kind of growing path. That's at least my experience. And I already sent another one. It didn't went well, but I know why it didn't went well. It's because I didn't know enough. So my next one is about infrastructure for the connected cooperative autonomous mobility, which it kind of develops from this. But now I just joined the CAM. I don't know if you're aware of it. CAM is a kind of working group at the European level to understand what is the next mobility. And I just want to go there and learn, make the right expertise, and then going again.
Thank you.
You asked us what do we think, what association do we have with SMART? And I was thinking that you were going into the SMART acronym. What is it?
Sustainable, multifunctional, automated.
No. It's the M is measurable, the A is achievable, the R is realistic, and the T is timely, and the S is specific.
Specific, yes.
But you don't have that connection at all with the acronym SMART.
Next project.
Okay, yeah, because I thought that's usually what they associate with SMART. Okay, thank you.
Sorry, I have a correction on this point. SMART acronym means Storm Water Management and the Road Tunnel. No, this is what, which is in Kuala Lumpur in Malaysia. It costed a fortune. It's a tunnel with 3 parts.
Yeah.
The lowest one is always a drainage tunnel. The top 2 are used for traffic, and when trains...
Microphone, please. Microphone.
Sorry. You cannot... Yeah, so it's an 11-meter diameter tunnel with 3 sections. The lowest one is always a drainage tunnel. The other 2 are used for traffic, and then when a flood comes, then they close it for traffic and open it for runoff water to flow. So that's smart.
Interesting. Well, we go back to the first question. What is a smart transport infrastructure, right?
Thank you. Anyone else? Yes, please.
Thank you, Davide, for sharing your ideas with
Welcome.
us. I think they are going to be an inspiration for other disciplines also. My question is related to self-healing asphalt. What types of capsules do you use for that purpose in order to keep them for breaking during mixing, but still to enable breaking when actually needed? Because it's a problem with self-healing concrete also, so that's why I'm asking.
It is a very good question. Well, first of all, it's not my expertise, but I know a little bit of what they collected. It's Álvaro Garcia, anyway, just for you to know the name, from Nottingham, called Álvaro Garcia from Nottingham. Feel free to contact him. So this research, Álvaro actually had an idea by looking MasterChef. So they did the emulsion, and then they found a way to have capsules that are, as you say, they resist the mixing, but then they can be broken whenever there is a crack. And I don't know the detail of the material, so I can't tell you, but the PhD of Nilo, the guy that was here, actually studied a model to understand what is exactly the strength of the membrane so that they can use the correct material to resist mixing and break whenever is needed. Have a look at it. Álvaro Garcia.
Okay, thank you.
Thank you. More questions, discussions, remarks? Someone of online visitors over Zoom Zoom application? No?
Microphone.
You have mentioned that WPFG sensors.
You should put it closer.
You have mentioned that WPFG sensors, but I think you have maybe have problems with their temperature sensitivity.
Okay.
And is it a problem for the using, or it just you don't need a big accuracy of them?
Now this
So you can, so the temperature sensitivity is not
it's a
very
very good
important.
question. Each sensor in an asphalt is temperature sensitive. But the good thing of this one, that first of all is covered with some resin, okay? So that it is, you can also use it while you mix it. Not in this shape, but we made a shape that is round as a sphere, and you can even mix it with that. But basically this sensor, it's measuring the energy of deformation of the membrane. So it is dependent by temperature, but because we are doing relative measurement, we kind of pass that step. Okay?
Yes.
So it's not an absolute measure, it's always a relative measure.
That's what my question, thank you.
Okay. Professor Presti, thanks again.
Thank you, Mr.
Thanks
Chairman.
a lot.